a body is equal to the mass of the body and acceleration of the body. Okay, and okay, net force is equal to mass and acceleration of the body. This is valid when your mass of the body is constant. This is valid when the mass of the body is constant. So we will take the net force in the direction in which the acceleration is. Okay, if suppose this is some body and this body is moving in this direction with an acceleration a. Okay, then what we will write, net force on this body, net force on this body in the direction of acceleration, net force on this body in the direction of the acceleration is equal to the mass into acceleration. So I will use this. Okay, okay, so today we will discuss this pulley pulley system. So basically pulley system means this is one pulley. These are two masses, and here mass 2 is greater than mass 1. Here mass 2 is greater than mass 1, and this is the string, this is the string, and this is the string. This is the same string. Okay, this string is ran on this pulley, and this is another string. Okay, this is the connection, means this string is a connection between the pulley and this support. Okay, so this is the support here. So here we will assume that pulley is frictionless and massless. This pulley is frictionless and massless, and string is massless. This string has no mass, and string is inextensible. Inextensible means the length of the string during the motion will not change. So basically what we want to find, we want to find this is the condition given. Okay, this is the condition given. Here is mass 2, here is mass 1. So what will happen, this mass 2 is greater than mass 1, so this mass 2 will move in the downward direction. Okay, this mass 2 will move in the downward direction, and this mass 1 is move in the upward direction. Okay. Okay, so now what we will do, we will draw the free body diagram of mass m1 and mass m2. Then we will solve what will be the acceleration and what will be the tension. So when the pulley is frictionless and massless, string is massless and string is inextensible, so acceleration of both the masses will be same. Remember this point, if string is inextensible, this is the condition, then acceleration of this mass m1 and m2 will be same. Okay, so now we can draw the free body diagram for mass m1 and m2. And how we will draw the free body diagram? So this is your mass m1, this is your mass m1. So I have told you, first we will consider this mass m1 as a point mass. Okay, so here I have just made this large, but this is basically a point mass of point mass. Okay, so m1g will be in downward direction, m1g will be in downward direction, and from this mass, the tension in the string will be in this direction. I have told you the tension will always away from the body. Tension acts away from the body. So this is mass m1. Tension will act away from the body for this mass m1. And for this mass m2, weight will act in downward direction m1g. This weight will be due to the attraction between the center of the earth and this mass m2. And in this direction, this will be the tension. Tension is same because the string is same. Okay, so for mass m1, tension is in this direction, and this mass is going, m1 is going in upward direction with acceleration a. So what I have told you, that calculate the net force on this mass. Net force on this mass. How you will calculate the net force, Divyangi? How you will calculate the net force on this mass m1? Am I audible? Hmm. T minus m1g. Why not m1g minus t? Because this whole system is moving in this direction. Okay, so that is why I am taking this as positive, this as negative. Okay, this as positive I am taking, and this as a negative. So when you will calculate the net force on mass m1, you will write T minus m1g is equal to m1 into a. Okay, for mass m2, for mass m2, this is mass m2. So in downward direction, this is m2g. In upward direction, this will be the tension. Okay, there is no other force acting on mass m2. So this is going in downward direction, this is going in downward direction with an acceleration is. So take this as positive, take this as negative. So right here, net force on mass m1 is m2g minus t is equal to acceleration, means this is the net force, and net force is equal to the mass of the body, that is m2 into the acceleration. So this is our equation number 1, this is our equation number 2. Okay, so what we will do, we'll solve both these equations to get the value of acceleration and tension. So what I am doing, I am adding equation number 1 plus equation number 2. So when I will add, this will become T minus m1g is equal to m1a. This is equation number 1. And what is equation number 2? Equation number 2 is m2g minus t is equal to m2 into a. This is equation number 2. Okay, so we will add both the equations. So when you will add now, so this will become t, this t and this is minus t. So this will be cancelled out. So here you can write, this is very easy. Here you can write m2g minus m1g is equal to m1a plus m2a. Further, when you will solve it, you will take g common from here. You will write m2 minus m1 into g. Here a common, you will write m1 plus m2. m1 plus m2. So from here you can calculate the acceleration, that is m2 minus m1 divided by m1 plus m2. This is the acceleration of this system. And tension we can find when you will put this value of a either in equation 1 either in equation 2. So you can find the tension. Okay, for finding the tension, put value of a in equation 1 or equation 2. Okay, so this thing you can find by yourself. Okay, so basically I want to tell you how to draw the free body diagram and how to write the expression for second law for any body. Okay, so we'll solve some of the questions. So this is the first question. Find the acceleration of masses and tension in the string. Find the acceleration of masses and tension in the string. So uh, this is the pulley, and on this pulley two masses are there, like here. I have shown here also. So what is the acceleration? m2 minus m1 divided by m1 plus m2. Okay, so you can use this formula, m2 minus m1 divided by m1 plus m2. But I am drawing the free body diagram. Okay, I am drawing the free body diagram. Okay, so I am not using this formula, m2 minus m1 divided by m1 plus m2. So I am just using free body diagram I am drawing. So first we will draw for 5 kg. So for 5 kg here, uh, the weight of this will be 5g in downward direction and tension T in upward direction. Here 2g in downward direction and tension in upward direction. So for 5 kg, and this mass 5 kg will go in downward direction because this 5 kg is greater than 2 kg. So this is going downward direction, suppose with an acceleration in. So this will move in upward direction with acceleration. A. So now we can write the equation. Now we can write the equation. This will become T minus 5g is equal to mass 5 into A. This is equation 1. And for this mass 2 kg, this is going in downward direction. Sorry. Actually, this system is going in downward direction. So we will write 5g minus T. Okay, we will take this negative, we will take this positive. So we will write 5g minus T is equal to 5A. This is your equation 1. And for this 2 kg, you will write this mass is going up in upward direction. So you will take this as positive, this as negative. So you will write T minus 2g. T minus 2g is equal to 2A. This is equation 2. Okay, this is equation 2. So now what you will do, you will add equation 1 and 2. Add equation 1 and 2. So this T and this minus T will be cancelled out. So it will become 5g minus 2g. 5g minus 2g is 3g. And it will become 5A plus 2A. 7A. 7A. So from here you can get the value of the acceleration, that is 3g by 7. This will be the acceleration. Now with the help of this acceleration we can find the tension. So I am just putting this value of acceleration in equation number 1. You can also put the value of acceleration in equation number 2. You will get the same result. So from equation 1, so this is 5g minus T is equal to 5, acceleration is 3g by 7. So from here we can find the tension. So this is minus T, this will be 15g divided by 7 minus 5g. Okay, so this is minus T, this will become 15g minus 35g divided by 7. So this will become minus 20g divided by 7. Okay, so this minus and minus will be cancelled out. So tension in the string will be 20g divided by 7. This is the tension in the string. This is the tension in the string. Or you can use this formula also directly. Okay, you can use this formula also directly. What is M2? M2 you will take always greater mass. Okay, so M2 is 5. What is M1? 2. M1 plus M2 means 5 plus 2. Okay, and here there will be G also. Here there will be G also. So this is G. So here will be 3G by 7, your answer. 3G by 7 will be your answer. Okay, so here also there will be G. Okay, in this formula. Suppose this is the question. This question you want to solve. Hello, Divyangi and Joylin and Hiba. Are you getting? All of you?
Yes, sir.
Yes, sir.
If you have any problem, then you can just tell me. Okay. In drawing the free body diagram and all that, if you have any problem, then you can tell me. Okay. So now we are solving this question. Basically, this is some surface, and this is the pulley. This is pulley. And here is 1 kg mass attached with this string. This is the string, and this string is ran over this pulley, and this string after that attached with this 5 kg mass. And remember, here I have told you we will consider the string is inextensible, means the length of the string during the motion will not change. And string is massless also, and pulley is frictionless and massless. Okay, friction we will study. Next topic will be the friction. Okay, next will be the friction. So there we will consider the pulley will have friction. Okay, first thing, draw the free body diagram of both the masses to find the acceleration and tension. They are asking find acceleration of the mass and tension in the string. So you can take any mass. So I am taking 5 kg mass. I can draw the here. I can show the forces here also, but I am showing here. So this is 5 kg mass. Okay. I have told you to 5 kg mass to considered as a point mass. Okay. So I am just drawing it like this. Otherwise, this is the point mass. Okay. You can consider this as a point mass also. But for the proper understanding, there is a requirement of the. So this is the 5 kg mass. Okay. So what are the forces on 5 kg mass? What are the forces on 5 kg mass? So first force will be the gravitational force on this 5 kg mass in downward direction. That will be mg. Mg means mass into g. And another force will be the normal reaction on this 5 kg due to this surface. So normal reaction will be in upward direction. And another force will be this tension force. I have told you tension will act away from the body. So another will be the tension force in this direction. And this whole system, this mass will move in this direction with an acceleration a. Okay. And this mass will also move in downward direction with acceleration a. Why? Because I have told you why. So now there will be no motion along the y direction. There will be no motion along this direction, y direction. So net force along y direction will be 0, means n minus 5g is equal to 0. So n is equal to 5g. Okay, n is equal to 5g. But what is the net force along the x direction? That is t. And this net force is equal to mass into acceleration. So this is your equation number 1. Now for this 1 kg mass, now for this 1 kg mass, now for this 1 kg mass, okay, so 1 kg mass. On 1 kg mass, there will be one gravitational force, that is weight of this mass, that is mass into g. Mass is 1 and this is g. There will be one tension force. Is there any force? No, there will be no force apart from tension and this. And this mass is going in this direction. This mass is going in this direction. Okay. So with an acceleration a. Okay. So 1 kg mass. 1 kg mass, there will be an there will be a force in this direction, that is 1g. There will be a tension force in this direction, and acceleration is in this direction. So you will take this positive, you will take this negative. So you will write g minus t is equal to mass into acceleration. Mass is 1 kg, acceleration is a. Okay, this is your equation number 2. Okay, so what you will do, you will put t is equal to 5a here. T is equal to 5a here, you will get the value. So you will, when you will put t is equal to 5a in equation number 2. So g minus 5a is equal to a. So this will become g is equal to 6a. So acceleration of the system will be g by 6. Acceleration of the system will be g by 6. Now with the help of this acceleration, we can find the tension. What is tension? Tension is equal to 5a. T is equal to 5 times of a. So we can find the tension. T is equal to 5 times of a is g by 6. So tension will be 5g by 6. Tension will be 5g by 6. This will be the tension. So now I am telling one shortcut to solve the solve for the acceleration only. Okay, solve for the acceleration only. So this is your system, mass and pulley system. So what you will do, this is your okay. We want the acceleration of this. We want the acceleration of this mass m1 and m2. First of all, the acceleration will be same. First of all, the acceleration of m1 and m2 will be same. Remember this point, because the string is massless, the string is inextensible. Okay, the pulley is frictionless and massless. So what you will do, you will imagine that this system, you will just stretch this system like this. Okay, and you have placed this system on some surface, on some surface, and here m2g on this mass m2, you will suppose there will be a force m2g in this direction, and on this mass m1 there will be a force m1g in this direction. Okay, okay, now consider this as a system, whole system. I have told you what is system means. Okay, system. So this have one acceleration a in this direction, this have the acceleration a in this direction, because m2 is greater than m1. Okay, so whole system have the acceleration a. I have told you how to calculate the acceleration for the system. Net force divided by mass, net mass. What is net force? m2g minus m1g, m2g minus m1g divided by m1 plus m2. So your acceleration will be m2 minus m1 into g divided by m1 plus m2. Now see one question. This question, see this question. Here are two masses. If there are two masses, then to calculate the acceleration for you will be difficult. Okay, so what you will do now, you will use the shortcut. So how you will use the shortcut, you will just stretch this system like this, and you will imagine that this system is on this surface. Here is one 5 kg mass. Okay, and this is the string, and here is one 2 kg, here is one 4 kg. Okay, so these two masses will come in downward direction, have the acceleration in downward direction, and this 5 kg mass have the acceleration in upward direction, have the acceleration in upward direction. Okay, because 4 plus 2 is 6 kg, so this will become greater than this. So net means net force will be in this direction, or you can say this 2 kg and 4 kg will go in downward direction, this 5 kg will move in upward direction. So on this 2 kg and 4 kg, on this 2 kg and 4 kg, on this 2 kg the force will be 2g, on this 4 kg the force will be 4g, and on this 5 kg the force will be 5g. So what you will do, you will just show the forces. So on this 4 kg there will be a force of 4g in this direction, on this 2g there will be a force of 2g. I am not saying this is the reality, I am just saying that this is the trick. Okay, and on this a force of 5g will be there. You want the net acceleration, na? Then write the net force. What will be the net force? 4g plus 2g means in this direction net force will be 6g, and in this direction the net force will be 5g. Net force will be 6g minus 5g, that is g. And what is total mass of the system? 5 to 7 or 4, 11. So this will be your net acceleration. You can solve by the free body diagram also. Okay, you can solve by this method also, because here are the three masses, so that this formula will not be valid. This formula will not be valid. So in this way also you can solve, and that free body diagram method will always uh, applicable. Okay, always applicable. Okay, write down. Write down, all of you. Divyangi, uh, if you have any
Yes, sir.
doubt, then you can ask me.
So it's clear.
Okay, so now write down. Joylin and Hiva, if you have any doubt, then you can ask me.
It's clear, sir.
Okay, fine. Okay. This white color type is, you can, okay. Joylin and Hiba, should I scroll down?
Yes, sir. Yes, sir.
Okay. Completed, all of you?
Yes, sir.
Yes, sir.
Okay. Okay, should I scroll down? Vibyangi
Yes, sir.
and Hiba and Joylin?
Yes, sir.
Okay. And what is G? G is the acceleration due to gravity. G is the acceleration due to gravity. Okay. This have the value we consider 9.8 meter per second square. Okay. And this surface is a smooth surface. Here we are not considering the friction. In reality, there will be a friction. We know that. But here in this question, we have considered the surfaces are smooth. Scroll down. Completed. All of you.
Yes, sir.
Okay.
Yes, sir.
Okay. Joylin and Hiva completed this.
Yes, sir.
Okay. So write down this. Okay, so now we will discuss Newton's third law. We'll discuss the Newton's third law. Newton's third law. So basically, Newton's third law I will explain with the help of one example. With the help of one example, uh, have you completed this? Joylin, Divyangi, and Hiba
Yes.
completed
Yes.
this.
Yes.
Okay, so now we will discuss the Newton's third law and Newton's third law. I will explain with the help of one example. Suppose this is a block of mass m. This is a block of mass m here, and this is a surface. On some surface, this mass of m block of mass m is placed. So on this mass m, if I want to find what are the forces acting on this mass m, there will be one force mg in downward direction, and due to this surface, there will be one force. There will be one force. This is the mg we know. There will be one force now on this. Due to this surface, there will be one force, that is normal reaction due to this surface. Okay, apart from the mg is also there. Okay, so we can draw this like this: mg, and this is the normal reaction, like this. What is the cause of the normal reaction? The surface is providing the normal reaction to this mass m. Okay, now see Newton's third law: action and reaction acts on different bodies. Now what is action and reaction? You will say this m is acting, means due to this m on the surface, force mg is acting, and in reaction, this surface is providing the normal reaction. But this is not true. N and mg are not action and reaction pair. N and mg are not action and reaction pair. Basically, when we will read whole statement, according to the Newton's third law, action and reaction acts on different bodies. So N and mg is acting on the same body. So N and mg cannot be action and reaction. Second statement: action and reaction pair are of same nature. Okay, are of same nature means I will explain later. Force always exists in pair. So basically, first statement you should know: action and reaction acts on different bodies. Okay, now what is action and what is reaction here? So basically, if I separately draw this surface like this, so due to this, actually this will be the condition. Due to this surface on this block, there will be one normal reaction, and due to the block on this surface, there will be one normal reaction. These are the action and reaction pair. This is the normal reaction on the block by surface. Okay, and this is the normal reaction by the on the surface by the block. Now what is mg? Basically, mg is the gravitational force applied by the earth. So this will be the earth now, like this. You will say this is also earth. This is earth, but this is just the surface of the earth. Okay, I am talking about the whole earth. Whole earth is applied force mg. So this earth is applying mg on this mass m, In turns, this mass m is applying mg on the earth. This is earth. So basically, action and reaction acts on different bodies. So this is action force. This is action force, and suppose this is reaction force, and this is reaction. Here, if this is action, so this will be the reaction. Okay. See here. Now second statement. This is the normal reaction. This is the normal reaction. So second stage, and this is the weight. This is the gravitational force. This is the gravitational force. Second statement. Action reaction pairs are of same nature. Same nature means same nature. Normal reaction, normal reaction. Action reaction have same nature. This is also normal reaction. This is also normal reaction. This is this is a gravitational force. Action force is the gravitational force. Reaction force is a gravitational force. Means action force and reaction force are of same nature. Okay, so action force here is a normal reaction. Reaction force is here a normal reaction. Action force here is the gravitational force. Reaction force is the gravitational force. Third, force always exists in pair. Means force always exists in pair. For example, oh no, it's okay. Now focus on this pen. If I am applying some force on this pen in this direction, if I am applying some force on this pen in this direction, then this pen will apply, the same force, this pen will apply the same force on my finger in this direction, This is the phone, okay? This is phone. And if I am applying, suppose this pen is applying, this pen is applying some force on this phone in this direction, then this phone will also apply the same force on this pen in this direction, okay, in this direction. So action, the force applied by the pen on the phone. Reaction, force applied by the phone on the pen. For example, this is the pen and this is my finger. Suppose this pen is applying some force on this finger. In turns, this finger will apply an equal and opposite force on this pen. That is why force always exists in pair. There will be two forces, one will be action, another will be reaction. There is one pair, so force always exists in pair. Yeah, gravitational force of mass and earth are equal. This mg and this mg will be equal.
Okay, sir.
Basically, gravitational force between the two bodies. Just I am explaining. Give me a minute. What is happening here? You will say Earth has a large mass, so he will. No, this will not the case here. Basically, when we will study the Newton's law of gravitation, we will see if two masses are there, m1 and m2 masses are there. The Newton's law of gravitation says that the force between this gravitational force between these two masses is directly proportional to the product of the mass and inversely proportional to the distance between the masses. So all these things we will study in the gravitational force. All these things means the gravitational force, Newton's law of gravitation. So force is given by G m1 m2 divided by r square. Okay. So this this force is on this mass. This force will be in this direction, and on this mass, this force will be in this direction. Because basically, this gravitational force is attractive in nature. This gravitational force is attractive in nature. For example, this is this mass. For example, this is this block. Here is the block, and here is this Earth is very large Earth. It will be very large Earth. So basically this earth has this center. So this earth has a mass capital M. This block has a mass M. So what happened? This is the line joining the center. So this earth will apply a force of G M into M by distance, suppose R square. Okay, distance is R square. And here this mass will apply a force, same force, G small m capital M divided by R square. Then you will say, why I have written this like this? Why? Because this G is given by Gm by R square. We will study this in the gravitation. So when you will write Gm by R square as G, so this is M, this is your Gm by R square. So instead of this Gm by R square, we can write Mg. So all these things we will discuss there. Okay. Okay, now so you can write here. There is a confusion I know in and mg. If this mass is m placed on some surface, so you will say here will be the normal reaction like this. This will be the normal reaction by this surface. So you can write here N and mg are not action and reaction pair because action and reaction acts on different bodies. For example, here is this monkey. This is the monkey, and this monkey is climbing this rope. This is a rope, or you can say this is a string. That's climbing this rope. So what this monkey will do? This monkey will apply an action force. Suppose the action force is F. This monkey will apply an action force F in downward direction. So you can draw like this. This is the string. So this will be the force F by the monkey. What is this F? Action force. Now on this monkey, this is monkey. On this monkey, this string will apply the equal and opposite force. This will be the reaction force. This will be the reaction force. Why string? Why rope, you can say. Action force, why monkey? Now we will solve one question. This is the question. This monkey is going in upward direction. Okay. And is climbing the rope. Okay, this is the monkey, and acceleration of the monkey is 2 meters per second square. Mass of the monkey is 20 kg. G is 10. Find the tension in the string. So now how you will find the tension in the string? So this monkey will apply a force. Some force this monkey will apply. Okay. Now we will draw the free body diagram of monkey. Free body diagram of monkey. So this is the monkey. This is a monkey. So what will happen? This monkey is uh, monkey have this rope. So this rope will apply an equal and opposite force, and that equal and opposite force will be the tension in the rope, and here will be the mg of the monkey in this direction, and monkey is going in upward direction. This is the monkey force. So this monkey force will be okay. This is T is equal to, I can write ma plus mg. So I can take m common. This is a plus g. What is m? 20. What is a? 2. G is 10. So this will become 20 into 12. This will become 240 Newton. So 240 Newton will be the tension in the string. Another question. In this question, they are saying there is a monkey, and this monkey, these are the bananas. So this monkey wants the banana. So this monkey will climb this. This monkey will go uh, to the bananas through this rope. Okay. So this monkey will have the upward motion. So the acceleration of the monkey will be in the upward direction. So they are saying with what acceleration the monkey can safely climb the rope. Okay, safely climb the rope. Mass of the monkey is 80 kg, and they are saying maximum tension that rope can bear is 100 Newton. Maximum tension this rope can bear means this rope will not break. After 100 Newton, this rope can break. So we will draw the FBD of the monkey. This is the monkey. So suppose this is the monkey. So this monkey have weight in downward direction, and there will be the tension in the string in upward direction, and this monkey is going in upward direction. So what will be the equation of force? This is T minus mg is equal to ma. So this is T is equal to m. Oh, sorry. We want to find the acceleration. Huh? So what we will put T, because they are saying with what acceleration the monkey can safely climb the rope. Okay. So but maximum tension is given. So this will be the maximum tension. This will be the maximum tension that the rope can bear. So we will put here 100. Okay, this is 100, and this is minus mg. M is 80, g is 10. M is 80 into a. So this will become tension is 100. I think this will be 1000. This will be 1000 Newton. So this will be 1000. 1000 minus 800. This will become 200 is equal to 80 a. So acceleration of the monkey will be 200 by 80. Cancel out. This will become 10 by 4, and this 5 by 2 means 2.5 meter per second square will be the acceleration with what the monkey can climb this rope safely. Okay. So what is happening here? Now, what is happening here? See how I have drawn the free body diagram. Again, I am telling this monkey is applying some force. in downward direction. In return, this string is applying the same, or you can say equal and opposite force, and that force will be equal to the tension force in the string. And here that tension will be the maximum tension that this rope can bear. Okay. Okay, so now write down. Divyangi and Joylin and Hiva, got it now? Newton's third law.
Yes, sir.
Yes. Yes, sir.
We say na Newton's third law, for an every action there is an equal and opposite reaction. So now what you will say, the Newton's law, action reaction acts on different bodies. Action reaction pair are of same nature. Force always exists in pair. That statement is not fully correct. For an action there is an equal and opposite reaction. For example, I give someone a slap, and in return he give me a slap. That will be also the action and reaction, but that is not the that is not connected with the Newton's third law. Okay, so basically Newton's third law says about the force, but if he is slapping me, like here he is slapping like this here, so here my fingers, these fingers applying the force on my cheek will be the action, and my cheek will apply the same force on the finger in the opposite direction. Here this law will be valid. Here we can say this is Newton's third law, but that is not the Newton's third law. For an action there is an equal, for an action there is a reaction, or you can say there is an opposite reaction. You can say for every action force there is an equal and opposite reaction force. This will be correct, I think. Divyangi,
Yes, sir.
but in your school, is your teacher completed the pseudo force? Have he or she teach the pseudo force?
No, sir.
Okay. Weighing machine? Okay.
Written.
Written? Okay. This is your monkey. Free body diagram of monkey. Basically, this F is action and this F is reaction. As monkey is going upward or climbing the rope, so acceleration will be in upward direction. This is the acceleration of the monkey. Completed?
Yes, sir.
Bianchi completed?
Sir, here tension is not the reaction, no?
Here tension is the reaction. Because this first, suppose this is the rope and the first monkey is just stretching this rope in downward direction. That is why this monkey is climbing. So this is the action force, and this is the action force, and there will be a reaction force also according to the Newton's third law. That reaction force will be the tension force, and according to the Newton's law, action and reaction are equal. So this tension force will be equal to this F, or you can say
Sir,
this F. Yeah.
sir, but this F is acting on the string and tension is also on the string itself.
Yeah. Basically, this F is, I have just written at this F. Okay, this is T basically. Okay, this is T basically. Both are same thing. This F and this T both are same thing. Means what I want to say, na? This F is the reaction force. This reaction force will equal to the tension that will be produced in the string. Okay.
Yes, sir, and the reaction is happening on the monkey, not on the string.
Mhm. Because action reaction acts on the different body. Scroll down, all of you.
Yes, sir.
Yes, sir.
Okay. Here, this tension force is a reaction force. This monkey is stretching the rope in downward direction. So due to that, there will also be a tension in the string in this direction. Means if we consider monkey, then this tension force will be the reaction force. Completed. Okay. So